In this video, I'll show you the derivation of what has been called by many the $1,000,000 equation. First, let's consider this one, which says e to the ix is equal to cosine x plus I sine x. So how is this true? If we see the Maclaurin series expansion of both sides, we can see that there is a correlation among them. The MSE of a function f of x is equal to f of 0 plus f prime of 0 times x plus f double prime of 0 over 2 factorial times x squared plus f triple prime of 0 over 3 factorial times x cubed plus f fourth prime of 0 over 4 factorial times x to the power of 4 and so on. So now let's consider f of x to be e to the power of ix. Then f prime of x will be I e to the ix, and f double prime of x will be I square e to the ix, and we know I square is -1, so it will be negative e to the ix, and f triple prime of x will be negative I e to the ix, and finally f to the fourth prime of x will be negative I square e to the ix, which then will turn out to be e to the ix. And their respective values evaluated at x is equal to 0 are f of 0 will be 1, because if I put 0 in this x, I'll get 1. And f prime of 0 will be I, f double prime of 0 will be -1, f triple prime of 0 will be negative I, f fourth prime of 0 will be 1. Now you can see that the reason I'm going until the fourth prime or the fourth derivative is because it cycles at that point. You can see that we had 1 at first, and then we went to, and then we get I, then we get -1, negative I, and back to 1. So you can see that if I had f fifth prime of 0 will be I. Now, we said that f of x looks like this. F of 0 plus f prime of 0 times x plus f double prime of 0 over 2 factorial times x squared plus f triple prime of 0 times x cubed over 3 factorial plus f fourth prime of 0 times x to the power of 4 over 4 factorial, and so on. Now, if f of x is equal to e to the ix, then f of 0 is 1, because it's 1 in here, plus f prime of 0 is I times x, plus f double prime of 0 is -1, so it will be -1 over 2 prime times x squared, plus f triple prime of 0 is -I times x cubed over 3 factorial, plus f fourth prime of 0 is 1 over 4 factorial times x to the power of 4. Finally, f of x will then be simplified to 1 plus ix minus x squared over 2 factorial minus I x cubed over 3 factorial plus x to the power of 4 over 4 factorial, and so on. So this is for f of x is equal to e to the power of ix. Now, if we consider f of x to be cosine x, we would have f prime of x will be negative sine x. F double prime of x will be negative cosine of x. F triple prime of x will be sine x. And f fourth prime of x will be cosine x. Likewise, their respective value evaluated at x is equal to 0 will be f of 0 is 1, f prime of 0 will be 0, f double prime of 0 will be negative 1, f triple prime of 0 will be 0, f fourth prime of 0 will be 1. Here also, as you can see, it cycles on the fourth term. We had 1, then 0, then negative 1, then 0, and back to 1. So if we say the MSE of f of x is f of 0 plus f prime of 0 times x plus f double prime of 0 over 2 factorial times x squared plus f triple prime of 0 over 3 factorial times x cubed plus f fourth prime over 4 factorial of 0 times x to the power of 4 and so on, then f of x equal to cosine x will be f of 0 is 1 plus f prime of 0 is 0. So this term will be 0 because, as you can see here, this is 0. So I don't need to write it. Plus f prime of 0 is negative 1 over 2 factorial x squared plus f triple prime of 0 is also 0. So this term is 0 because this term is 0. Plus f fourth prime evaluated at 0 is 1. So I'm going to put 1 over 4 factorial times x to the power of 4 and so on. Then this will be simplified to 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial and so on. So this is the MSE for cosine x. Finally, let's consider f of x is equal to sine x. Then f prime of x will be cosine x. F double prime of x will be negative sine x. F triple prime of x will be negative cosine x. F fourth prime of x will be sine x. And their respective value evaluated at x is equal to 0 are f of 0 is 0, f prime of 0 is 1, f double prime of 0 is 0, f triple prime of 0 is negative 1, f fourth prime of 0 is equal to 0. So, likewise, if the MSE of a function f of x looks like this, f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial plus f triple prime of 0 times x cubed over 3 factorial plus f fourth prime of 0 times x to the power of 4 over 4 factorial and so on. So for f of x equal to sine x, f of 0 is 0 because, as you can see, it's 0 in here. So I don't need to write it. This is 0. And f prime of 0 is 1 times x plus f double prime of 0 is 0 in here. So I don't need to write it. Plus f triple prime of 0 is negative 1. So I'm going to put negative 1 times x cubed over 3 factorial. And f 4 prime is 0. So I don't need to write in here because it's going to be 0, and so on. Then this will be simplified to x minus x cubed over 3 factorial, and so on. So this is the MSE for sine x. So we solved the MSE for 3 functions: for sine x, for cosine x, and for e to the ix. Let's put them in one equation. Remember, we had e to the ix is equal to cosine x plus I times sine x. So I'm going to substitute here, here, and here. Keep in mind that I'm going to multiply sine x with I. For e to the ix, we have 1 plus ix minus x squared over 2 factorial minus ix cubed over 3 factorial plus x to the power of 4 over 4 factorial. Now for clarity, I'm going to put cosine x and sine x with 2 different colors. So for cos x, we have 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial plus, and so on. Keep in mind that there is a continuation in here. Plus I times x minus x cubed over 3 factorial, and so on. This will be equal to 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial plus, and so on, plus ix minus ix cubed over 3 factorial, and so on. Now, since addition is a commutative property, I can put 1 plus ix minus x squared over 2 factorial minus ix cubed over 3 factorial plus x to the power of 4 over 4 factorial. You can see that this is 1 in here, and the ix came from here. Then I wrote this one, and then I get ix to the power of cube over 3 factorial from here, and finally this one is from here. So you can see that the left hand side and the right hand side are equal. So we proved that e to the power of ix is equal to cosine x plus I sine x. Now let's put some values in place of x. Let's consider x is equal to pi. Then this will turn out to be e to the power of I pi is equal to cosine of pi plus I sine pi. We know from trig that sine pi is equal to 0, so this will turn out to be 0. Then we would have e to the power of I pi will be -1 because cosine pi is -1. Now let's add 1 to both sides. So I'm going to add 1 in here and 1 in here. Now this will equal to e to the power of I pi plus 1 is equal to 0. So this is what has been called the $1 million equation. And the reason for that is because it consists the 5 most fundamental constants in mathematics put together in one equation. We have 0, we have 1, we have I, we have pi, and e. I hope this was clear. Until next time, peace.